All right, everyone. Let's get this started. I didn't bring my whistle in. So, hi, everyone. This is the Warren Astronomical Society. Welcome. We're at Macomb Community College, South Campus. I am the president, Bob Tremblay. Do we have any first-timers here, other than our speaker? No, okay. Well, I don't have to go through that spiel then. If you want to renew your membership, which you should, you can do that via PayPal on our website. And David is not here, so you can't do it here. Our talk tonight is Mass Extinctions by Andy Epton. Okay, roll calls. Let's go through roll call. I'm Bob Tremblay.
Eduardo Saluso. Bob Berta.
Dale Harden, first vice president.
Dina Wong, secretary member.
Wallace.
Sonny Spilos.
Maria Boznak.
Tom Servant.
Jeff McLeod. Mike McDowell.
Pete Lemire.
All right, and we've got several people online. Hi, guys. There, hi, guys. All right, so okay, so announcements. We have the Ford Club Swap Meet on April 5th, 9 a.m. to 3 p.m. Mark Kedzier is going to have a table. They're selling stuff. The WAS is probably going to get a table and just be selling the club. Well, not off, but promoting the club. So yeah, I'll be there. Tina said she might be there. If you want to get a wash t-shirt or wearables, they are available from Mark Kedzier in our newsletter. The annual picnic date is the 23rd, August 23rd. The Great Lakes Association of Astronomy Clubs meets every Tuesday. We met and we were looking for a speaker, and I found out that Brother Guy is going to be in town that weekend. It looks like if he's not going to be speaker, he's going to be at a table under the club tent. So he'll be there both nights or both days. So I've let the GLAC board know that he's willing to be speaker if they want him. And I got one guy said, cool. And that's all I got response back. So we'll see if Brother Guy is speaker. He was a guest of honor via Zoom on 2019 when we had the COVID run. But he's written like 2 books since then, and my God, his schedule is so crazy. He is in Rome one week and the U.S. the next. It's nuts. But anyway, so Astronomy at the Beach is September 26th and 27th. It is the same date as the Great Lakes Stargaze, and we're not really sure why, because the Great Lakes Stargaze usually likes to do it on a weekend when there's no first quarter moon. They chose the same weekend, so I don't know if we're going to be having, dueling telescopes or what, but so we'll see how that works out. But so far right now, they're both the same weekend. Jeff McLeod has been showing up at GLAC meetings, or he showed up at the last one. Yay. If anybody else wants to show up. One of the things that it looks like they're going to want to do this year, and you brought up some good things this time, was helpers for the telescopes, because there were people in very long lines for telescopes who didn't know why they were in very long lines. Okay, that's a problem to begin with. And, they'd be in line to look at Jupiter, and then when they get there, the person would switch to something else that they'd already seen that they'd been in line for 2 hours for. So, yeah, so we're gonna work on some logistics about that. So we had a lot of volunteers for the Cranbrook Planetary Alignment event on Saturday, March 1st. We had 7 telescopes out there. It was awesome. Cranbrook was flipping out happy about all that. So expect them to invite us back to do the same thing sometime. So Dale is looking for presentations for 2025, both short and long. If it's long, it's later in the year, right?
Disappearance of the traditional elite class and a collapse of central administrations and centralized economies.
Somebody talking there? Okay, Riyadh, what's going on with the observatory? We have a Stargate night in 2 days.
Yes, we do. So last open house, we got clouded out. We had about 8 or 9 people that stuck around. We talked about astronomy in general, the club and telescopes. But that was about it. So hopefully in 2 days from now, looks like we may get some break in the clouds. So come on out there. It starts at 7 o'clock. And let's see if we can get some clear skies.
All righty. Thank you, Riyadh. Let's see. David, you are online. What is going on with the Treasury?
We got lots of bucks. So let's see. So I did make I did send a $500 cash deposit to the Ukrainian club. They promptly cashed it. So we got a reservation there for the end of the year dinner.
Nice.
So we got that done. I paid for the post office box for the year. So we got that done. Updated our IRS tax status. So that's done.
All
And
right.
then let's see.
Oh, cool. Anything
Let's
else?
see. In the checking account, we got like $23,516.
Spend some of that money.
PayPal, we got 937. Cash box, we got about $250 in there. So we got bucks to spend.
All right, and if if Jeff is successful at selling some of our old telescopes at the swap meet, we'll have even more bucks to spend. Yay!
Somebody's
All
got to find a
right.
way to spend this money.
Secretary Charlie, what is up? Whoop, oh, you're muted. Can I unmute you? I can't unmute you. You're muted, Charlie.
Hey everybody, I'm Charlie Strackbine and I'm the secretary of our organization. And what I have to report is that meeting notes are ongoing and that you will see them for the March meeting letters. You'll see meeting notes you'll see in the April newsletter. Look forward to that. And that's my report.
All right, thanks, Charlie. Outreach, Jeff. We got any requests from scouts coming in yet or anything like that?
No.
We gotta fix that. We need to do some promotion or something.
Well, if you're available, you can do it.
I am. I want to start speaking.
Here we are from Southern Jupiter. Bob covered the Ford swap meet. That's kind of the next big thing that's coming up. And maybe he didn't sell it good enough. It's not just a swap meet. There's lectures and other things going on. It's a good time. Starts early, goes through most of the day. So there's a lot to do there. They also have like food, donuts, pizza, that kind of stuff for a small fee. Mark Kedzier had a thing, but I think it got canceled because of the weather. Dale Parton did some stuff with Girl Scouts. Brownies. It'll be in the write-up. We got a good picture. I got permission to publish the photos they sent us in the newsletter. I'll be back when we do observing reports, but since the last meeting, so the what do you call it? The Cranbrook meeting was the anniversary of Apollo 9 launch.
Mhm.
It splashed down on the 13th, about 15 days later. The 16th was Gemini 8. That's the one that almost killed Neil Armstrong. That's a good one. That's all I got.
Cool.
All right. Yeah. If you got outreach stuff, let me know so I can get it in the newsletter.
All right, and publications is up. So there's Dale. Our newsletter is up. Our award-winning newsletter and our award-winning newsletter editor are online. So if you need to contact the board, you can contact us at board@warrenastro.org. Let's see. David Levy. Is that David Levy? I see a David. Is that David Levy? No, don't think so. You usually have his picture. All right. So astronomy in the news. Wow. Firefly Aerospace, a private aerospace company, landed the Blue Ghost lander on the moon on the 2nd. And it was there on the moon when the eclipse happened on the 13th, and it was looking back toward the Earth, and it did this, and I will show this to our audience. Share that. Share that. So there you go. That is the Earth's atmosphere being completely illuminated by the sun from a camera on the moon looking back. And I've seen some people comment on social media that this ranks right up there with the pale blue dot, and I'm kind of right there with them. This just blew me away. I was literally running around the house with my arms flapping when I saw this.
There was a similar photograph taken by Apollo astronauts, just not quite.
Really?
Yes.
I was unaware of that.
They flew into the shadow of the Earth itself and got the ring effect.
Did they?
Yeah.
I will have to find that. I was unaware of that.
It's one of the later ones. 16 or 17, I want to say.
But anyway, there's video of that thing landing, and what's really amazing is, that it kicked up this huge dust plume, which settled in seconds, just gone. And there was actually a plume experiment. One of the concerns they're having is that future missions that are going to land on the moon are going to kick up so much crap that some of it's going to get into orbit and become a hazard. There's actually an experiment on this lander that was looking at analyzing that. So that's pretty cool. Let's see, back over to that is not the right one. I've got too many windows open. There we go. That's the right one. All right. So we are up 22 exoplanets to 5856 and up 153 candidates. And Barnard's star, they found 3 new planets, so it has a total of 4 now. And if you hadn't heard, Saturn has 128 new moons, bringing up to a total of 274. Yikes. Almost as much as the rest of the solar system combined. Or
do you know what's like diameter they're down to?
they're small. They're kilometer. Yeah. They're tiny.
Wow, did they discover planets around Alpha Centauri?
Yeah. Yeah, there's I think there's 2 confirmed, 1 candidate. They're not sure about one of them yet. Well, yeah, they're there. Okay, so something on spaceweather.com that was pretty interesting this morning is that there is evidence that cosmic rays spark lightning, which I've suspected actually for a while. That says the report it's on Space Weather says every second almost 50 bolts of lightning zigzag across the skies on the Earth. Despite centuries of studies, however, researchers still aren't sure how they get started. Electric fields and thunderclouds are often too weak to ignite a powerful discharge, and it goes on that they've linked lightning discharges to the hits of cosmic rays, which is happening all the time, everywhere. So this is the sun today. Let's see if we're gonna share that. Get it over onto this screen. Share the sun. All right, so and it shared the screen and that. All right, so darn it all. All right, there's the sun today. Zoom. Share that. Okay, lots of sunspots. Lots of big ones rotating out of view. So we are still at solar maximum. And get that back over here. Get a presentation. All right, so Riyadh, I imagine you're going to be seeing double stars. You got anything planned to see on Saturday?
Well, yeah, I mean, we're still looking at some of the winter skies, so same thing as before. If we can get a hold of a couple of the items, the objects that are very interesting in Orion and in Canis Major, of course, then we'll be looking for them.
Well, I didn't even look up on spaceweather.com about T Corona Borealis. Is it just the same? No updates?
Yeah, I haven't heard anything yet and nothing new.
Still
By the way,
waiting.
I just want to remind people also, April is around the corner, and April 12th, we have the statewide astronomy night.
Oh,
which we may have a lot of people showing up at Stargate. So anybody who wants to help, you're
ooh.
welcome to come and attend.
I will send a mailing out to the membership about that, because that's something we should do. I should include the swap meet too. So I will do that tomorrow. All right, so observing report. So first thing I got here is some pictures of the eclipse. And let's see. Open with photos. Bring that over here. And then I'm gonna share that, and then I'm gonna cycle through these things. Resume. Oh, share that. Right, so let's cycle through these guys. You want to give a commentary on this? You don't? No, okay. All right, so just cycling through. This is every 15 minutes, you said? This is with what, a C star?
Yeah, sea star.
Did you set that up to do it automatically, or did you have to every 15?
No, I had to do it. I sat out there the whole time. Doesn't have a timer on it. There's no way to make it do that.
You should submit a couple of those to the newsletter. All right.
Oh, feel free to use them.
There's a lot of pictures. So did you say you had something?
Oh, yeah.
What do you got? Presentation.
Playing the part of Gary Ross tonight.
Oh, you're just doing it by oh, okay.
I have data.
No, you don't. Look at this here.
Yeah, if I move it, it stays. So Dale Parton has probably also done this. You can time the particular staging of a lunar eclipse and use some simple geometry to get an estimate of the distance and size of the moon. I did a presentation on this years ago. And so every eclipse, I try to get another data point. So from the horse's mouth, the moon is 296.9 thousand miles away. Anyone?
Close.
It's about 18% too far. You didn't find those photos, did you? Did you find those photos I sent you?
Oh, hold on, I will.
Hold on, I got a marker. This will work. So, shadow of the Earth.
Let me get
Right.
rid of my
The
background
moon went
here.
across the bottom. So what happens is the moon makes first contact. This is hard to draw. I should exaggerate. Did you find it?
Oh, I'm sorry.
Did you find it or no?
I'm looking.
Don't worry about it. Basically, what happens is the first contact is not the same as when the moon is completely into the shadow. There's a little difference because of it not passing directly through the center of the shadow. So when you're timing it, it makes the moon bigger and the shadow smaller. And essentially, when you crunch the numbers, that ends up making it appear as if the moon is further away. However, with your photographs, you can trace that this shadow of the Earth and get a better estimate of the size of that shadow compared to the moon, maybe get closer. Yeah, okay, so this is not this eclipse, but this is a composite. Oh, but it's not on the...
It will be. Oh, hey, wait, stop that. Do that. There we go.
So this is a different eclipse, but you can clearly see the size of the Earth's shadow. And then if you go down to the next one.
Here, where is it? That one. This is what we're looking at, these pictures.
Yeah, so
This
scroll
guy.
down. So you see here, this is first contact, but totality doesn't start until you've crossed all this extra distance. And that extra distance is essentially air. That's why we keep doing the measurement over and over and over again to try to get a better average. So if you go back and watch my presentation, I got to within 5%. That was in part one due to me using Dale Parton's estimate for the size of the Earth, which was a little undersized, which means when I said it was further away, that brought it in a little bit. And then the errors of my water clock also helped me get it close. So I got close by accident.
So, the moon's orbit around the Earth is somewhat elliptical.
Correct.
Did you use the average distance to the moon or the actual distance?
So for this one, I went online and actually found like the distance on the time, and it's off by 18%. I don't know if I even listed it here, but we were pretty close to Appamun or whatever it's called.
Apolloon.
Apolloon, yeah. The farthest distance the moon is from the Earth. I don't know for the 2014 eclipse that I did. I'd have to go back and look at it.
You're slipping.
Not worth it. You give me the timing in 1950, whatever they.
Any other observing reports? Anyone online? Doug, come on, nothing new?
I'm sorry, but I've had medical issues for the last 6 months.
Oh,
I haven't
well,
got.
drat, hope you feel better. All right, well, I don't have a sea star, so I don't have any pictures. So, if that is it, then we're close. Let's take a 20-minute break. Do we want to take more than that? It says 8 o'clock. That's going to be a half hour. That's a bit long. 20 minutes it is. Come on back at 10:02 and we will start our feature presentation. So let's start doing some munchies. So go do a bio and they break. Come back at 10:02.
So I have one, that is the entire type scale at 1/18 scale. It's, like this PVC fiber when I painted and then I printed the top and bottom. It's a low resolution, but like from 6 feet away, it looks great. And I've been telling him like the Bell model, you know, and it's a three.
My wife put a box of Thin Mints in here.
80s or something. And they re-released it for like the 50th anniversary or something, and so I picked one up and I used to have it sitting there. Not much of a but I also purchased a file for the model. Like it would 3D print all the same parts. And I can build size. So I want to print one. It's gonna fully working doors and interiors and everything. One, not the height, just the, you know, upper section and the outer section. At 1/12 scale. I 1/6 scale. And I'm like, God, my first number. But that's kind of a.
I think about 6-7 months.
All right, 2-minute warning.
Yeah, but
Let's get your presentation up.
Iceland is too expensive, and you have the probability that there will be clear skies. It's really because
Yeah, I think,
Iceland weather.
Ken Burton said they're going to.
Iceland weather.
I think the last one he was plotted out was also up in that neck of the woods. All right. Pleasure.
Yeah, you gotta keep experimenting.
Until next time.
Wow.
Yeah, when I said get some star, I got that calibrated and then really dial in the floor. We're northeast, south.
Look it up.
It's like the sun.
Yeah, okay. Oh, maybe it's right, so.
But that's like, it's like 220.
Okay, so you just get good points.
Why is it showing that?
Where I go is on Cadillac.
Well, I don't know what I'm gonna do. Degrees away from
That's better.
I have a buddy who lives
Right. Head down.
Well, you know, the one thing I do, once I get everything set, we hopefully out there, it's like the bar, so negative.
All right, Dale, you ready to go? Can you guys hear me? Testing, testing. All right, they can hear me. All right, Dale, you wanna introduce our speaker?
Yeah.
One I really like is the Joby and Stephen Lake one. That one is no afraid.
Is that?
First thing I did, we got to
Sold their houses. And they all moved up there. Yeah.
It took me a long time to also. I was out in
All right, you ready? Dale? Dale? Ready?
They had nothing to employ the local population. They moved them up there with like, you know, basically his staff, but all his.
I can't get this pinned. Well, I can't get this pinned. Yeah, speaker. I get this. Why can't I get just his picture there? All right, well, we're gonna do the intro here with this picture and then, all right. All right, everyone. Start.
Okay. Before I introduce our speaker, let me just say that at our next meeting at Cranbrook, Tom Otvos, who's in Canada, will be giving us a presentation called Bleeding Edge Telescope Making, a survey of what's possible. And he did some, I wouldn't call it original, but innovative kind of ways of making a serious sized lens for a reflector telescope. And also our own Bob Tremblay will give a short presentation on the basics of how to use stellarium to see what the sky looks like. A month from now, here when we're back here at Macomb, Dr. Nicole Zellner from Albion College will give a talk. She kind of specializes in studying the moon. So her talk will be the moon, what we know, and why we're going back. I'm sure that'll be a really interesting talk. Tonight, Andy Epton, who is originally from South Carolina, is here. He has a degree in geology. He teaches earth science, astronomy, and environmental science at the Henry Ford Academy in Dearborn, Michigan. He was recently selected as the Michigan State winner of the Outstanding Earth Science Teacher in 2023. Has a passion for rocks, fossils, and Earth's history, which I'm also interested in, and I'm sure a lot of you are. He also has a strong interest in astronomy, as he's certified to handle moon rocks with your bare hands.
Well, they're in lucite discs, but
Yeah.
yeah.
Is a solar system ambassador and works at Longway Planetarium in Flint.
What we do? That whole town.
His presentation tonight is on mass extinction events. Andy.
All right. All right, so let's take this over here. All right, and this just scroll forward.
Okay.
With the mouse. There you go.
All right, so yeah, I'm gonna do talk about mass extinctions, but I'm mainly focused on, are we in one right now? Yeah, that's kind of where we're leading to with this. Are we in a mass extinction? I'm sure you already know the answer to that, but we can use the past to kind of explain or understand how we got to where we are or what we're experiencing right now. So first off, mass extinction, what is it? Mass extinction is a short period in Earth's history during which rates of extinction reached exceptionally high levels. I got these definitions from various dictionaries online. A rate of extinction increases with respect to the background extinction rate and rate of speciation. And it was popularized by a guy named Georges Cuvier. There's the mass extinction. The blips right here, these high peaks are the mass extinctions. And look, there we go. Georges Cuvier kind of popularized this notion of mass extinction back in the late 1700s, early 1800s. He was a French anatomist and it was famous for being able to put together an animal based on a single bone. And he was really good at it. And people were bringing him bones of elephants, and he's based in Paris. And he's like, where are these elephants coming from? And so he started reasoning that maybe, in fact, there were elephants at one point in time in the Paris region, and they've been wiped out. They're now extinct. So he kind of formulated this notion of catastrophism that kind of ran into against this notion of uniformitarianism, one of the early scientific feuds of the day. Background extinction, what is it? I already mentioned the background extinction. Well, basically, the background extinction rate is a natural offshoot of natural selection. So this line right here shows the background extinction rate of the last several million years. And you have these very high peaks that show up above that, especially this one right here. That's a really high peak. So that's basically what's going on with the background extinction rate. And it's estimated to be about 1 extinction per million species years. that means for every million species, or if you have a million species on Earth, there's one going extinct every year. So that's what that rate means. And so this is part of natural selection. Charles Darwin was no fan of mass extinction, but he was okay with extinction. His natural selection basically stated that animals are going to go extinct. They're just naturally selected against, and they're going to go extinct. So he was okay with that, but mass extinction, catastrophism, as Georges Cuvier was theorizing, he was totally against that. He thought that it was a very gradual process. He could not see a giant catastrophe happening and wiping out large portions of the planet population. Thomas Jefferson actually did not believe in extinction at all. He refused to accept extinction on a pure kind of religious founding. He could not imagine a creator creating something and then allowing it to go extinct, which means that when he was president and he sent out Lewis and Clark to the Pacific Ocean, he tasked them with bringing back a mastodon and a mammoth because he had bones of them. They were collecting bones from Kentucky and Ohio and parts of Virginia and Pennsylvania. And he thought, we just haven't found them yet. So he sent Lewis and Clark out to go bring one back. And of course they didn't because they're extinct. But again, Jefferson just refused to accept that. So Earth's history. I am not going to go through the entire geologic timescale with you. You're welcome. But because I could very easily and I enjoy it thoroughly. But this is Earth's history. And we are currently, of course, up here at the top, and the bottom is the oldest stuff. And we're going to start in this area right here with the Ordovician extinction. There's my little arrow going up there. So the Ordovician extinction is our first major mass extinction. Yes.
For our online audience,
Yes.
they cannot see your.
I know they can't see my pointer.
It'd be helpful if you use the mouse pointer on the screen.
Okay. I will certainly do that right here. So I'll do that instead of laser pointer. That's fine. So anyway, we're going to start off right here with the Ordovician extinction. And basically what happens is the culprit is climate change. Bum, bum, bum. Climate change rears its ugly head a lot throughout the Earth's history. And it's one of those things that people understand happens. But when we get to the modern extinction, it's something that understanding what happened in the past will definitely allow us to see what's happening today as being something more sinister, if you will.
Was that the oxygenation?
No, this one was, I believe, just a change in the climate caused by massive volcanic eruptions. This is the deoxygenation. So there it is. I knew it was coming up at some point. Hypoxic and anoxic oceans and possibly holes in the ozone layer. There's some ideas that maybe the volcanic eruptions were so significant that they punched holes in the ozone layer. And so 85% of marine species went extinct. This is the one I know the least about. I'm sorry, but I know the least about this one. It is the second biggest mass extinction, I will say that. And it was devastating. But again, everything was in the water at this time. So when we're talking about marine species, we are talking about everything being in the water. So this was a huge deal for the populations of the planet. So what went extinct? Corals. Corals go extinct a lot. They're very susceptible to extinction. They're very sensitive. That's the word I was looking for. They're very sensitive to changes in the ocean, temperature, acidity, composition, all of that sort of stuff. They're very, very sensitive. So they're going to go extinct a lot. Bivalves. Bivalves like clams and pelecypods and some brachiopods go extinct at this time. And my favorite, the trilobite. Not all trilobites go extinct. They still rule the oceans, in my personal opinion, for several million more years, but a lot of families did go extinct at this time. So there was a great diversification of trilobites, and then some go extinct, and then another great diversification of trilobites, and then the Devonian extinction. So moving on to the Devonian, right there. This one happened over a period of time. This one is not a single event. This particular extinction took place in pulses, we believe. So culprit, anoxic oceans, yet again. So how do the oceans get anoxic or become anoxic? Once again, volcanism is probably playing a part in this, but also something called eutrophication. Eutrophication is this notion of nutrient pollution. It's one of my favorite words to say, eutrophication. And what's happening is we think that this is after life has started to populate land, and plants themselves are causing this eutrophication event. So as nutrients wash into a waterway, they start to cause algal blooms. And there was algae back then. There's been algae for billions of years. We know of cyanobacteria, aka blue-green algae, dating back to at least 3.5 billion years ago. So there was definitely algae happening at this time. Well, these algal blooms will block sunlight coming in from above and prevents photosynthesis at the bottom of the water columns. That's going to cause the plant life down there to start dying off. Meanwhile, the algae themselves are going to start dying off as well. They don't live very long. And as a result, they're going to pull oxygen from the environment as they decompose. And so as they pull oxygen from the environment, there's less and less oxygen available for the multitude of fish that live in the water at this time. This is the age of fish. Fish were everywhere at this time. This is also the time of, fish moving onto land and becoming amphibians. So this is killing off the fish. They're suffocating, and other marine organisms also are suffocating. And when I tell students this, they're like, fish can suffocate? Yeah, fish can suffocate. Very much so. So the fish are suffocating. They're starting to die off. That's pulling more oxygen out of the environment, and it just becomes anoxic. It becomes an anoxic environment. Anoxic means no oxygen. And this actually possibly was caused by, or could be caused by, global cooling. As opposed to global warming that we're so used to with climate change, this is potentially a global cooling event. So the volcanism because volcanoes are not all the same. Some volcanoes spew a lot of ash and debris into the atmosphere. Some are kind of what we call flood basalts. These were the ashy volcanoes, and these volcanoes blocked out the sun, causing a decrease in temperature and an increase in ice. And so mass glaciation occurred during this time, and that possibly led to a mass die-off on land as well as in the waters. So what went extinct? There's trilobites again. Trilobites go extinct. Again, not all of them. They're resilient little critters. Corals, it's again very sensitive to the changes in the ocean. And placoderms. Placoderms, this is Dunkleosteus here. Probably the most famous placoderm in history. Placoderm means armored skin. Basically, it's the armor shell of the head piece of the fish. So these were armored fish, and this is by far one of the biggest, and again, one of the more famous of the placoderms because of, people love nasty things, and this was certainly a nasty thing. T-Rex, Velociraptor, Dunkleosteus, they love those things. If it eats other things, they're like, yeah, let's go for it. So again, that's Dunkleosteus, the placoderm. But again, this happened in pulses. So again, the glaciation possibly happened over a course of several million years. toward the end of the Devonian period, which led to this mass extinction. Moving on to my personal favorite mass extinction right there at 252 million years ago, the Permian extinction. This is my favorite because it is probably one of the least known in terms of a popular understanding, but this was the worst one, without a doubt. This is the worst one. Volcanism and climate change killed off 95%, approximately 95% of all species on planet Earth. It brought life to the brink of annihilation. And it started off with, again, volcanism in what is known as the Siberian traps. So where Siberia is today, it was not there back then. It was actually part of Pangaea. But a massive volcanic rift opened up and it just poured what we call basalt, this volcanic rock, out in multitudes over thousands of years, just kept pouring basalt out, which also poured out lots of gases, specifically greenhouse gas carbon dioxide. And so as the carbon dioxide increased in the atmosphere, that led to rapid climate change. The oceans turned pink. Why did the oceans turn pink? Because of a deoxygenation of the water. Because hot water doesn't hold on to gases. And so as the water warmed up from the climate change, it started releasing all of the gases that it was holding on to. Carbon dioxide is one of them, oxygen is another. And there's a particular bacterium called purple sulfur bacteria that thrives in anoxic environments, and it turned the oceans pink as a result. Yeah.
So with all the talk about the oceans warming up, is there a tipping point that you know of that caused this heating of the ocean that caused the oxygen?
I don't personally know. I'm sure there are some books out there that I could read and figure that out. But this took place over the course of thousands of years. So, and I just don't know what that tipping point is. I know that the oceans are the biggest heat sink in on the planet. So right now, we're pumping out all this carbon dioxide into the atmosphere and everything, and the oceans are absorbing a lot of that heat that is being produced or, kept onto the planet. It's absorbing a lot of that, such that we could actually be twice as warm as we currently are, but the oceans are absorbing that. How much more they can hold, I don't know.
It happened in the past.
Yes, this has happened in the past, and that's why understanding the past extinctions can help us figure out what's happening today. Because we can look back at the Permian extinction and go, well, this happened. When did this happen in the course of the extinction, and where are we at in the course of the extinction? So as the oceans begin to become anoxic and turn pink, they're also releasing hydrogen sulfide gas, which is toxic. So the animals living close to the oceans, if they haven't already died from the extreme heat, because the animals living on land at this point, vertebrates anyway, are primarily reptiles and amphibians. And so they're cold-blooded. And as a result, they're not going to deal well with the extreme changes in temperature. And so those that are still alive living near the coast are breathing in this hydrogen sulfide gas. So they're going to suffer. Then the hydrogen sulfide is mixing with water in the atmosphere, coming down as acid rain. It was a nasty, nasty situation.
And the driver is volcano.
The driver at this point was volcanic activity. That is without a shadow of a doubt for us. It started off what it's called a positive feedback loop, where the increased temperature of the atmosphere heated up the oceans, which released the carbon dioxide, which continued to heat the atmosphere, which continued to heat the oceans. It also set free some frozen methane called methane hydrates, which we will revisit in just a little bit when we get to our modern extinction. at least in a previous warming period that will kind of color how we're looking at today's extinction. So this was, again, the granddaddy of all extinctions, without a doubt. And again, it brought life to the brink of complete collapse. And it took a long time for it to recover. But what went extinct? Well, we have our trilobites finally bit the dust on this one. They went extinct. They were in the oceans for 300 million years, and finally the Permian extinction got them. Eurypterids or sea scorpions went extinct at this time. And these guys, these are not dinosaurs. That for whatever reason, and I grew up loving dinosaurs, and I still do love them to this day. For whatever reason, every little kid kit for dinosaurs has one of these things in it. This is
Plastic one of those on my desk.
this is a Dimetrodon.
I do.
And it is a mammal-like reptile. It is closer to related to mammals than dinosaurs. But they went extinct during this particular time period, during this extinction. Luckily, not all mammal-like reptiles went extinct, because otherwise we would not be here. So luckily we are, and we can talk about this particular extinction. But those particular guys right there, the Metrodons, the Dilophosaurus, and so forth, they went extinct. So moving on to another extinction, not long afterward, you would think the Earth would be like, okay, that was a bad one. Let's give it a little bit of time. Nope, about 20 million years later, we have another extinction event. This was a pretty bad one too. Volcanism, once again, is the culprit. And climate change. 76% of all species go extinct. This is when basically the Atlantic Ocean is opening up. So Pangea is coming to a close. It has had its time, and now it's starting to open things up. And as it does so, there's a lot of volcanoes happening in the central portion of what was Pangea, what is today the Atlantic Ocean. That led to global warming and ocean acidification. Ocean acidification plays a part in all of the extinctions, essentially, because once you increase carbon dioxide levels, especially if it's global warming happening, you're going to have acidification in the oceans. But it played a bigger part in this particular extinction than, say, the others. So what goes extinct in the Triassic? Everything but the dinosaurs, essentially. So we have the Etosaurs. We have the Phytosaurs, and we have the big bad guys, the Rauisuchians. These were the dominant organisms on land during the Triassic. It was not the dinosaurs. Dinosaurs are related to them. They're like the distant cousins. It was these guys that dominated land. But during the Triassic extinction, for whatever reason, they were unsuited for the changes happening on Earth, whereas the dinosaurs were just fine. Yeah.
What's different about these from the dinosaurs?
I don't know. I have my own ideas. And my idea is that these were more cold-blooded than dinosaurs. There's some debate as to whether or not dinosaurs were warm-blooded or cold-blooded, or what they sometimes call dinosaur-blooded, serving as a transition into birds, because we know birds are dinosaurs. And dinosaurs are related to reptiles. So it's a matter of, where did that transition happen? Did it happen with the dinosaur lineage? Were they able to withstand this particular extinction because they had a special way of warming their bodies compared to their cousins, who are very much not dinosaurian? So, I mean, the Phytosaurs there, I mean, they look like giant crocodiles, really, except for the Etosaurs. Yeah.
That seems like a lot of these things were based on volcanism or volcanoes. Do we understand why we have these periods of large volcanoes?
It's a tectonic activity.
I mean,
so with this particular one, you have to basically the Atlantic Ocean opening up. And so you have this massive volcanism, this rift area. that is opened up inside the middle of Pangea, and so it's just spewing out lots of magmatic material, and so that's also spewing out a lot of carbon dioxide as well. Why that particular one caused a mass extinction and not some of the others that we experience? Because right now the Atlantic Ocean is still opening up. It's underwater, but it's still moving. You know, it's moving at about the same length, just same rate your nails grow. So why that's happening then? Maybe because it's on land.
It wasn't
And
global
everything else is
warming that
underwater.
caused the volcanism. It was definitely the volcanism that caused the global
Yeah.
warming. So
Yeah.
it wasn't like the global warming created other things that were triggered.
No, not in this particular case. We will see that climate change can cause a lot of things, but one of the things that it doesn't necessarily lead to is volcanism. It does lead to ocean acidification. It can lead to eutrophication. It can lead to even global cooling, in a way. So it can lead to a lot of things that can cause mass extinctions, but in this particular case, these were mostly volcanic inspired, which kind of means that what we're doing today is we're taking the place of the volcanoes, essentially. And I've got some graphs to show that, I think I have the graph that shows what volcanoes do versus what we do, comparatively speaking. All right, this is the best known that people probably think of when they think of mass extinctions here at the end of the Cretaceous period. 66 million years ago. This is probably the one that's most, kind of in league with what you guys do here, because this is the bolide impact, the asteroid impact, and volcanism. So the thing that I like about, or the thing that I want to point out about most of these mass extinctions, it's not one thing that necessarily causes it. It's one thing that can trigger, but other things are happening as well. And so with this, we know we have, beyond a shadow of a doubt, evidence that there was an asteroid impact. We've got it, the Chicxulub crater. It's the smoking gun right there at the Yucatan Peninsula. Prior to 1980, you would have been laughed out of the room if you suggested that the dinosaurs were killed by an asteroid impact. There were multitude of theories, but an asteroid from space was not one of them. In fact, the people who suggested it, the Alvarezes, Walter and Luis, they were laughed out of the room. But when they found the Chicxulub crater, that kind of sealed the deal for them. And then once that happened, every extinction ever in history became an asteroid impact. They looked for evidence of asteroid impacts for the Permian extinction, for the Ordovician extinction, for the Devonian. But the only one they found real true evidence for was for this Cretaceous extinction. Deccan traps, again, this is something we know happened. We have the evidence. So did the impact cause the Deccan traps to erupt? Did the Deccan traps cause the dinosaurs to die off? We don't know. That's the thing. We know both of these happened at geologically about the same time. So we can't just sit there and point, well, it was definitely the asteroid that killed off the dinosaurs. No, it was the volcanoes that killed off the dinosaurs. We have evidence for both of these things. So both of them definitely happened, and both of them are part of the Cretaceous extinction event. So, and then of course we have our favorite, climate change. Because you're going to have climate change. When you have an impact the size of the impact that killed off or that led to, helped the demise of the dinosaurs, you're going to have climate change, massive climate change happening. You're gonna block out the sun for years with the debris thrown up from that. You're gonna have forest fires spewing out massive amounts of carbon. You're gonna have just vaporized rock in the atmosphere, doing all sorts of things, weird chemistry happening in the atmosphere from the vaporized rock. So you definitely have climate change. And then, of course, you have the Deccan Traps spewing out carbon dioxide as well. So these things kind of conspire to kill off every child's favorite, the dinosaurs. So we have the marine reptiles go extinct. We don't have any marine reptiles anymore, Loch Ness Monster accepting. Good old Nessie. What would we do without her? The ammonites and other shelled creatures like them went extinct. So we only have the nautilus left in terms of chambered shelled creatures. And then, of course, my personal favorite, always the dinosaurs go extinct. The non-avian dinosaurs, I do have to make sure I say that, the non-avian dinosaurs, because avian dinosaurs, of course, are still around. And the irony of all ironies, chicken nuggets shaped like dinosaurs. So, a dinosaur-shaped dinosaur. But yeah, the dinosaurs go extinct. There seems to be a weight limit that most everything, or not everything, but a lot of went extinct were over 70 pounds. And the things that survived were under 70 pounds. That is a little bizarre. It's not exclusive, meaning some things obviously were bigger and survived. Sharks survive. Sharks are the never, ending lineage in the ocean. Crocodiles survived. Crocodiles are bigger than 70 pounds. But it seems that in terms of birds and dinosaurs and some of the marine reptiles and things like that, things bigger than a certain size all went extinct for whatever reason. Now, all of that said, we are now into the last period of the last era of the geologic time scale. So the last 66 million years. And that's what we're going to be kind of using the last 66 million years as a reference for what's happening today. So I start off with the PETM. PETM is short for Paleocene Eocene thermal maximum. That occurs at the edge of the Paleocene and the Eocene epochs, about 55 million years ago. CO2 levels went as high as, or were up around 1,200 parts per million, possibly as high as 1,600 parts per million. We're currently around 423 parts per million, just as a reference. So we're not there yet. But that's the part, that's the scary part. The yet is the scary part. Because during the PETM, it was not a mass extinction. It was a time of insane warmth on our planet. Obviously, the Antarctica was not frozen over yet. We had palm trees in what is now Alaska. We had crocodiles found above the Arctic Circle. So, in the last 66 million years, the shape of the Earth in terms of the continents hasn't really changed all that much. India, yes, has kind of run off and rammed into Asia. But generally speaking, in terms of where the continents are, they're essentially where they were back then. There hasn't been all that much changing going on. So when I say above the Arctic Circle, I mean, in North America, above the Arctic Circle, there were crocodiles, and crocodiles don't live there anymore. At least they shouldn't. I would hope not, because it's really cold. So possibly what started this PETM business? Volcanic activity yet again. So the volcanoes erupted, melted those methane hydrates at the bottom of the ocean, set off a massive amount of carbon into the atmosphere, and that led to this increased warming. Now, here's the PETM, alligators in the Arctic. Sounds like the name of a bad movie. And then we're down here today. Actually, we should run that up just a smidgen because we're above 400 now. This was a little bit dated here, but still, we're kind of on this uptick right here. So we're nowhere close to the PETM yet. So what's happening today? The age of exploration and the Columbian exchange have altered Earth's surface. The flora and fauna, we're making it a more homogenized Earth. We're taking things from our home countries and bringing them to our adopted countries to make it look like home to us. That's in bringing in a lot of invasives. The overuse of fossil fuels have raised carbon concentrations to, again, it says 417. I think the last time I checked, it was like 423. So I made this a little while ago, so still. Plus, I was using the 423 is Mauna Loa data, which is not necessarily the global average. So it's probably just a little bit less than 423, probably around 420. So we're going to take the middle range there. So about 420 parts per million for global average concentration of CO2. And then the concentration could be as high. I've seen various estimates of this as high as 900. That's PETM levels as by 2100. That's 75 years from now. 75 years from now, we could be at PETM levels. Now, what about the PETM? It took 20,000 years. 20,000 years for the carbon concentrations to rise up to where they were during the PETM. 20,000 years. If we take the beginning of climate change to be the beginning of the Industrial Revolution around the year 1700, we're going to do it in 400. That's 50 times faster than the PETM. We're going to reach the PETM levels 50 times faster, assuming nothing changes, because business as usual is business as usual. So what else? Well, we have the megafauna extinction. So again, looking at our modern extinction, we have to talk about the megafauna of the Ice Age. Between 50,000 and 10,000 years ago, the large Ice Age animals went extinct, the famous mastodons and mammoths and giant ground sloths and saber-toothed cats, dire wolves, short-faced cave bears, all of those creatures went extinct. This corresponds to human migration patterns out of Africa and across other continents. It also corresponds to the end of the Ice Age. So what caused the megafauna extinction? Was it overhunting? Possibly. Was it the end of the Ice Age altogether? Possibly. It's one of those questions that we're still debating. We're still arguing amongst scientific circles. The overhunting theory is definitely one we're looking at because we find these animals with spear points in them. So we know they were hunted. Did we overhunt and kill them all? Because we can. Well, if we look at modern equivalents, we could have. The age of exploration. Here come the humans. Humans began to set sail. Islands were hit especially hard. Island biogeography is crazy. They are sensitive. They're like coral reefs. They're incredibly sensitive to any small change. And once the humans arrived, things were never the same. This is the great auk, the original penguin. The great auk lived in the northern latitudes. Not the southern latitudes where all penguins live today. This is the original penguin. That's why it looks like a penguin. In fact, it was called a penguin. And when they killed them all, they discovered a bird that lived in the southern hemisphere that looked a lot like the great auk, and they decided to call them penguins. Sailors discovered they could walk up to these flightless birds and hit them over the head with a stick and then eat them. So they did. All of them. Stellar sea cow. Stellar sea cow was discovered or named by George Steller on a Russian fur trading expedition in the early to mid 1700s. This dugong, relative of the manatee, swam up to the boats because it didn't know what a boat was. It didn't know what a human was. It soon learned, though. Unfortunately, too late for it. The sailors discovered it was full of blubber and meat and apparently tasted really good. So they annihilated them. hoping that there were more around the next corner, around the next Aleutian Island, and there weren't. Within a matter of decades, the stellar sea cow goes extinct. This is the poster boy of extinction, the dodo. The dodo lived only on the island of Mauritius. It's a fairly large flightless bird, about the size of a turkey, and it didn't know what humans were. And sailors once again discovered that it had no fear of them. Everything else had fear except the dodo, and the dodo became this poster child of extinction and for whatever stupidity. But it got eaten to extinction. The moa, the giant moa. These were actually kind of farmed, if you will, in New Zealand by the native tribes of New Zealand. But once the Europeans arrived, they did not last long. They only lay one egg a year, and it's a big egg. And so it fed a family. But if you take their eggs, they're not going to reproduce as fast. And so, they were, again, farmed to a degree, but they got annihilated as well. This is not my fun, happy-go-lucky slideshow, but this is reality of the situation. We're talking about extinctions. So the moa, the stellar sea cow, the dodo, and the gray auk are just a handful of mass extinction events that we have to deal with. I can't remember the bird's name, but there was a bird that was discovered near Cincinnati, or no, not Cincinnati. It was in Missouri, and it was discovered in the early 1900s. And the person who found it realized it's the last of its kind, and they shot it.
Passenger pigeon?
Could have been the passenger pigeon, but I think it was different than the passenger pigeon. But the passenger pigeon is another extinction event. Once in such multitude that it would darken the sky for days as they migrated, the passenger pigeon. People would go up on their roofs or outside their homes and just shoot into this multitude of birds to see how many they could hit. Not to eat, just to see how many they could knock out of the sky. John James Audubon described the passenger pigeon migration as being deafening. He hated the passenger pigeon migration. But we don't have passenger pigeons anymore. Carolina parakeet also met the same fate. So there's lots of examples we could go through and talk about. But the Columbian Exchange kind of helped facilitate some of this. Columbian Exchange refers to the exchange of plants, animals, people, culture, ideas from the old world, Europe, Africa, Asia, to the New World, the Americas. And of course, disease came with that. And this particular exchange facilitated an invasion. You here in the Great Lakes, it's my adopted state, yes, but y'all know very well of the lamprey, the zebra mussels, the quagga mussels, and goodness only knows what else is out there. That is part of the Columbian Exchange. We think of Columbus as being this thing that happened hundreds of years ago, but we're still part of it. Everything we do is still part of this Columbian Exchange. So native species have taken a humongous hit as a result. So this is facilitating that extinction is, again, human caused. So there's the Columbian Exchange, there's the lamprey, the zebra mussels, the scourge of the Great Lakes. Extinction rates. So here's my problem with the mass extinction thing. I 100%, I think we're in a mass extinction, but here's where I raise questions. Is there a recency bias? Because in the fossil record, we don't have a perfect fossil record. Not everything that died got fossilized. And even those that did die and got fossilized, we haven't found all of them yet. And we may not find all of them because of tectonics and weathering and just accidental destruction or wanton destruction of these fossils. So when we talk about an extinction of the past, we're looking at where a fossil is and then it's not. So we have fossil evidence of these things, and then boom, it's not there anymore. Today, though, we can watch things go extinct, such as the golden toad here. The golden toad is long thought to be, or has basically become the poster child for climate change and extinction. It's the first organism that we know to go extinct because of climate change, modern climate change. It lived in the Central American highlands, and it basically survived off of a fog that existed in the highlands, and it would reproduce in the puddles because it's an amphibian and needs to lay eggs in water. Well, with climate change, the weather patterns have shifted in those highlands and the fog is no longer there. And so the golden toad is extinct as a result of that shift in weather because of climate change. So this is the golden toad here. So we can watch things like that go extinct, and it's an amphibian. So amphibian bones are notoriously hard to fossilize because they're soft body organisms. They have bones, yes, but they're usually very small. And you have to die in a certain spot at a certain time and get the right conditions. And it just doesn't usually work out for them. So we may never have known the golden toad existed if we were, say, thousands of years in the future, looking back at history, we would not have the fossils of it. So we can watch these things happen in real time. We can document the moa extinction, the dodo extinction, and things like that. So is there a recency bias? We talk about extinctions happening almost all the time. But is it because we can watch them in real time, or is it actually a mass extinction? I think it's a mass extinction. So here is a few or a graph here showing start of the Industrial Revolution. They moved it to 1790. I personally think it should start a little earlier than that, but still, it doesn't matter. You see that mammals have gone up as far as extinctions, birds especially, all vertebrates. And then the background is down here at the bottom. So clearly there's a lot of die-off happening. There's a massive die-off happening. So again, does this mean we're in a mass extinction? So a new age, the start of the Anthropocene. I am a big proponent of the Anthropocene. I don't care what the supposedly know everything's and the geochronology specialty says. I think we're in the Anthropocene. It's really just a matter of when does it begin. That's the only bugaboo that they're having to figure out. But whatever the case may be, something is happening and it has to do with humans. We're living in the Holocene, but I personally think we're in the Anthropocene. Anthropocene means recent human. Humans have definitely impacted the geologic record. We have radiometric isotopes that we have created through atomic weapons. Sorry? Well, anyway. We have radiometric isotopes found in the soils from nuclear weapons. There's a lot happening, and of course, the climate change situation. So, culprit, us, to be determined, the extinction total. When will this end? Will it ever end? We're in the middle of a mass extinction. We can't look back on it and go, oh, well, this happened and this happened and this happened and this is the reason. It's happening right now and we're in the middle of this. And it is a lot to do with climate change. I keep bringing it up, and I am very passionate about this particular topic. We have the Antarctic temperature down here. We have atmospheric CO2 concentration. A strong correlation between these two graphs. Strong correlation. The greenhouse effect. When I was coming through school, I was taught the greenhouse effect was bad. It's not bad. It's necessary. We have to have it. It's the reason why we're not a dead planet. But we're exacerbating the situation. And so it is a problem. And these are some of the emissions possibilities. Billions of tons of CO2 per year, business as usual, we'd reach about 150 almost billion tons of CO2 per year by the year 2100. These others are if we started mitigating, which we're not really doing a very good job of. We have too many people who still believe that we are no longer are not experiencing this. This is a hoax and all that sort of stuff. The atmospheric CO2 at this level would be 1,255 parts per million. Between 910 and 1255. So that's PETM levels by 2100. And again, that's bad. This is very, very bad. This would cause, the Antarctic ice sheet to melt and the Greenland ice sheet to melt and all these other things to melt and all this other stuff. So, it's just erase sea levels. It would cause all sorts of untold destruction. So anyway, again, I come back to the PETM because over the last 65 million years, that's the high point. We can't, you can compare it, what's happening today to say the Cretaceous or the, previous time periods. Oh, there was no ice age, there was no ice during the Cretaceous. Yeah, there's also were us. We're ice age animals. We are around during the ice age. We're still in an ice age, but this is the kind of the high water mark. If we reach this, I don't know if we have a chance. I really, truly don't. Of course, there's hope. But, we'll see. And of course, this links to the world population. If you've never seen that, I highly recommend going to it. It'll make you depressed. It's a clock that basically shows the world population, and it's like 8.2 billion people right now. So, and it just keeps climbing. It just keeps climbing. So it's a problem. It's a major problem. So yeah, I feel like we're in a mass extinction. Where is this going to end? I don't honestly know. Is it going to be the extinction of humans that brings it to an end? I hope not, because I'm kind of partial to the humans. But this is going to take time. This is going to be long term down the road type of stuff. But we need to start. We should have started a long time ago. But in lieu of that, we need to start doing something. We need to do something now. But it's not just us. It's not a personal thing. It's corporations and businesses and all that sort of stuff. Bigger than us, bigger than the individual. Anyway, thank you. Any question? Yes.
It seems to me that the species you talk about are the species like the size of my thumb and up to tens of meters.
Yeah.
But there are many more.
Oh, absolutely.
Insects and bacteria species and all that kind of stuff. Did these mass extinction events affect them?
It's hard to say because those things don't really fossilize very well. We can always speculate, but we know that there were reducing atmosphere or environment, a reducing environment for the impermanent extinction, for instance. So in a reducing environment, there's going to be certain things that are not going to survive because they need oxygen. So even though we know that we don't necessarily have the fossils for them, they're going to die off in a reducing environment. And again, we know that it's a reducing environment because we find things like pyrite, lots of pyrite from the Permian extinction. Pyrite only forms in the presence or the absence of oxygen. Otherwise, it would be iron oxide instead of iron sulfide. So the geology tells us that it was a reducing environment, not an oxidizing environment. So I honestly, I don't know. We know, obviously some things have stuck around, like stromatolites. Stromatolites are the cyanobacteria that have been around for 3.5 billion years. We have stromatolites or we've had stromatolites in what is now Michigan, in the UP. But they're still around. We still have stromatolites in places like Shark Bay, Australia, and parts of South Africa, I believe. So they seem to be doing okay to a degree. They're still around. They managed to survive all these mass extinction events.
You should stay by the computer.
Yeah.
They can hear you.
Sorry, my teacher is coming out. I want to, wander. But yeah, so I think that honestly, some things did go extinct. We just don't have necessarily, or we haven't found the fossils of them. But I would imagine that there were lots of extinctions there. And again, that's part of that recency bias. We can look and see these bacteria, these small insects that don't get fossilized necessarily, dying today, going extinct. And how much of that was happening back in the other extinctions. Again, so that's the only kind of question I have for the mass extinction today is how much of it is recent? How much of it is that recency bias? Because we can watch these things go extinct. We can watch the panda, the cuddly pandas. Basically, it's a doomed animal. Is it going to go extinct? We're trying to keep it from doing that, but if you know anything about panda biology, those things are trying to go extinct. They have a hard time mating, and then when they do have babies, sometimes they just abandon the babies for whatever reason and have nothing to do with them, and then humans have to come along and raise the babies. So they're trying to go extinct, and we're trying to keep them from doing that. Koalas only eat eucalyptus leaves. No nutritional value whatsoever. They sleep all the day, literally all day, 23 hours a day. How much longer is it going to be until they're extinct because their food source, the eucalyptus, is gone? By the way, they're like ridiculously stupid animals. They won't eat eucalyptus leaves unless it's on a branch. You can put leaves on a plate, they won't eat it. They are ridiculously not very bright. But so they're kind of actively trying to go extinct in a way. Nature is selecting against them, and we're helping nature along, but we're also, in a way, there are those people that are trying to bring them back from the brink of extinction. So we're both causing extinction and keeping some animals from going extinct, either because they're cute and cuddly or because we're aware of their plight. And yet we're causing all these others to go extinct as well. So again, I find the recency bias to be really, really strong. But I'm sure we can find fossil evidence of bacteria because we have fossil evidence of bacteria. I just don't. Usually when people write books about it, they write books about the big stuff, the sexy stuff.
Any other questions?
Yes.
I have one. Recently, and I'm talking like 250,000 years ago to about 35,000 years ago, there were other species of humans on the planet. Homo sapiens are the only species left, and we had, well, Neanderthals the most famous, but there's many others that went extinct around the same time. Any thoughts on why that happened?
Can you summarize the question for
Oh yeah, so he asked about the other species of human that existed over the last several thousand years that are now extinct. And yeah, what happened to them? That is a very good question. I mean, how wild would it have been to like walk around a bend and see another human, but it's not the same human as you? That to me blows my mind. But what happened to them? There's some people who think that disease wiped them out. Others think that they, just didn't have the technology that Homo sapiens came up with, and we kind of outcompeted them.
Some say we interbred. I mean,
Yeah.
23andMe gives you a percentage of Neanderthal.
Absolutely. The Neanderthal is within us. So I don't know. This is one of those things that much smarter people than I probably have really good answers for or have an idea about. But I think that has to do a lot with, our technology versus their lack thereof possibly had a large part of it. I don't know. Neanderthals were pretty smart. We've discovered quite a bit about them over the last several years. They weren't the knuckle dragging dunces that cartoons made out to be. So, I mean, I grew up on Looney Tunes cartoons, so I saw the Neanderthal cartoons definitely. So yeah, I don't think that they were quite that way, but I think that something about Homo sapiens, we had an upper hand somehow or another. And it wasn't bigger brains because Neanderthals have bigger brains than us, so it was something. Something caused them to go extinct and us to stick around. But seriously, how wild would it have been to see another human, a different human? Yeah.
There's when were the salt beds of Detroit, underneath Detroit, laid down about, I think they're pretty old.
I don't know. I would love to know that. I would love to get in there. I didn't even know Detroit had salt beds until I moved up here about 5 years ago. Again, I'm a Southern boy. We learned about the Great Lakes, and I come up here and learned there's a massive salt dome underneath the Great Lakes, which is, fantastic. I would love to, as a geology person, I would love to get in there and just take some salt samples just for fun. I don't know. I honestly don't know. That is something that I would dearly love to know more about, is the salt and everything like that. I'm trying my best to learn as much about the geology of Michigan as I can, but that is one place that I am severely lacking, is that salt, that salt underneath the Great Lakes. Yeah.
Is Yellowstone Park and places like it a potential super volcano waiting to happen?
Yes.
Can
Yes.
you repeat the question?
So Yellowstone volcano, or Yellowstone National Park, is a super volcano. Is it a ticking time bomb, basically? And the answer to that is yes. It erupts approximately every 600,000 years, and it's been 600,000 years since it last erupted. Does that mean it's going to erupt like tomorrow? No. But in the next several thousand years, more than likely. When it does, we will hear it here. We will feel it here. We will probably be spared from most of the ash and debris from it, but it is going to wreak havoc on the world's economy and food supply. And it's going to cause probably a volcanic winter, as such. And there have been some speculation that we went through a bottleneck of sorts, like a few 100,000 years ago, or maybe in a few tens of thousands of years ago, where a super volcano erupted and caused a mass die-off, not a mass extinction because we're still around, but a mass die-off of humans. So, and it created a bottleneck, and then we expanded from there. And boy, have we expanded a lot. Yes.
We like to talk about mass extinctions, but there's the other end too, is that you have constant new species, either
Yes.
evolving, whatever. And
Yes.
the thing is, I've done study a lot of things that really interest me are how existing creatures on Earth have evolved to deal with very, unlifelike situations.
Yeah, the extremophiles. Yes, absolutely.
Water bears, the low end, but
of course, the tardigrades.
Creatures like at Mono Lake, I used to go to Mono Lake all the time and study the stuff there. Even the worms in Great Britain, which were found that were tender earthworms, and they were living on extremely contaminated soil full of arsenic, and they're able to survive only in the arsenic-laden soil. They can actually remove the arsenic from the soil.
Yeah.
And then you go down to the depths of the ocean where there's creatures down there that have never seen the sun. They live near volcanic vents. The
chemosynthetic organisms.
So there's a lot to be said about as creatures either evolve or they can no longer evolve, but they then become another
type of a species and move over, let another species take their place.
Yeah, I think the concern though is that we're seeing more extinction than speciation. So we're seeing a faster die off than we are seeing kind of this gradual changeover. And that's what Charles Darwin was kind of a popularizer of, was this gradual idea of natural selection changing the species on Earth over a given period of time. So he was never against extinction. He was just against mass extinctions because he couldn't conceive of a big catastrophe. But now with our, technology and our better understanding of geology,
And watching a asteroid plow into Jupiter.
exactly, yeah. Watching this happen live and going, holy crap, if it can do that to a gas giant, what would it do to our planet type of thing? So I think that's the big concern right now is we're seeing more die off than, new organisms coming about. And so that's why I think people, and honestly, people are more concerned with death than anything. If you take a look at the world clock thing that I showed, or that I had the link for there, that I didn't pull it up, but if you go to it, it's just world population clock. I show it to my students, and there's a total births, there's a total deaths, and there's a the difference, the world population growth. And my students are like, oh, that many people are dying. Not concerned with the overall growth rate, which is 100,000 per day plus, like almost 200,000 a day. They're concerned with the 100,000 that have died off, that have died, as a natural consequence of life. And I think people are kind of hyper fixated on that death aspect, and so that's why we look at mass extinctions with this fascination, and so forth.
All right.
Thank
you very much.
You're welcome.
All right. For our listening audience and for our audience here too, if you're interested in a science fiction book about the Yellowstone going up, Dennis Taylor Outland, and he obviously did a whole lot of research because he talks about all the time Yellowstone went up before and all the ash layers it put down, all this stuff I never knew about. So very interesting book, Outland by Dennis Taylor. So we meet afterwards at Kirby's Coney Island. Where we're going to the one on Van Dyke, or no, where over here? National Coney Island on 12 Mile. I'm sorry, on Van Dyke, north of 12 Mile.
Jimmy's is the bar.
Oh, the Jimmy's bar, right? It's right next to it.
But we have to get your order in before 10.
Yeah, Jimmy's.
Yeah, Jimmy's
Get there before that.
In Coney Island, and you have to go through Coney Island inside to get to Jimmy's. So they stay open later.
Okay, so yeah, we have an open house in 2 days at Stargate Observatory and National Coney Island. And with that, the meeting is over. Clear skies, everyone, and good night. What?
Snacks.
The snacks? What about snacks? I'm gonna send an email out with sign up sheet. So we need somebody to do snacks next time. I will be sending an email out and talking about the Ford swap meet. What was the other thing, Jeff? What was the other thing we had to do? I'll have to